Hello my dear students, welcome back to another lecture on numerical integration. In this lecture we are going to study how we can find the numerical integration of the function using Gauss integration. The integration of the function f of x from a to b with respect to x can be approximated using Gauss integration as the sum of the product of c sub I f of xi, where I runs from 1 to n. Here the coefficients c are known as weights and the points x are known as Gaussian points. For n is equals to 2, we can define this expression as c1 f of x1 plus c2 f of x2. For n is equals to 3, we can define this expression as c1 f of x1 plus c2 f of x2 plus c3 f of x3. Similarly, we can define it for higher values of n. Generally, Gaussian integration is for the intervals from -1 to 1. So the integration of the function f of x from -1 to 1 for n is equals to 2 can be written as c1 f of x1 plus c2 f of x2. Now here we have four unknown numbers c1, c2, x1 and x2. We need four conditions to find the value of these numbers. So we will assume that this integral equation gives us the accurate results for the values of the function f of x is equals to 1, x square and x cube. For f of x is equals to 1, this integral equation can be written as the integration of 1 from -1 to 1 with respect to x, that is equals to 2, and on the right hand side we will write c1 f of x1, which using this equation can be written as 1 plus c2 multiplied with f of x2. Using this equation, that would be 1. So that would be c1 plus c2 is equals to 2. For f of x is equals to 1, for f of x is equals to x, the integration of x from -1 to 1 with respect to x is equals to 0, and on the right hand side we'll write c1 f of x1, which using this equation is equals to x1 plus c2 multiplied with f of x2, which is x2. Similarly, for f of x is equals to x square, the integration of x square from -1 to 1 with respect to x is equals to 2 upon 3. On the right hand side, we'll write c1 x1 x square plus c2 x2 square. Finally, for f of x is equals to x cube, the integration of x cube from -1 to 1 is 0. And on the right hand side, we'll get c1 f of x1, which using this equation is c1 x cube plus c2 multiplied with the function value at x2. So that would be c2 x2 whole cube. Now here we have got four equations with four unknowns. c1 plus c2 is equals to 2, c1 x1 plus c2 x2 is equals to 0, c1 x1 square plus c2 x2 square is equals to 2 upon 3, c1 x1 cube plus c2 x2 cube is equals to 0. We can solve them simultaneously to find the values of c1, c2, x1 and x2. So when we solve them, we will get c1 and c2 is equals to 1, x1 is equals to -1 upon square root of 3, which in decimal number can be written as -0.577350027, and x2 is the additive inverse of x1, which is 1 upon square root of 3, that is equals to 0.577350027. Now substituting these values of c1, c2, x1 and x2 into this integral equation, we will get integration of the function f of x from -1 to 1 with respect to x, that can be approximated as the function value at -1 upon square root of 3 plus function value at 1 upon square root of 3. Now this formula is called Gauss-Legendre two-point integration formula. Similarly, for n is equals to 3, a is equals to -1, b is equals to 1, this formula can be written as the integration of f of x from -1 to 1, that is approximated as c1 f of x1 plus c2 f of x2 plus c3 f of x3. Now here we have 6 unknown numbers, that is c1, c2, c3, x1, x2 and x3. We need 6 conditions, 6 equations to evaluate these to determine the values of these unknown numbers. So we will assume that this integral equation gives us the accurate results for the values of the function f of x is equals to 1, x square, x cube, x power 4 and x power 5. Now for each value of f of x, we will get an equation. So for f of x is equals to 1 x square x cube x power 4 x power 5, in total we will get 6 equations. When we solve those 6 equations simultaneously, we will get the value of c1 and c3 is equals to 0.5555556, value of c2 is equals to 0.8888889, value of x1 is minus 0.77459669, x2 is equals to 0 and x3 is equals to 0.7745966669. Substituting these values into this formula, we will get the integration of the function f of x from -1 to 1, that can be approximated as c1 multiplied with f of x1, which is this value, plus c2, which is again 0.8888889, multiplied with the function value at x2, plus c3 multiplied with the function value at x3. And this formula is known as Gauss-Legendre 3-point integration formula. Similarly, we can also derive 4-point Gauss-Legendre integration formula. In general, if we want to evaluate the integral of the function f of x from a to b, we will first convert that limit of integration from a to b to -1 to 1. We will write the integration of the function from -1 to 1. Now the argument of the function has been changed from x to the variable t, where the value of x we have considered here is x is equals to b plus a divided by 2 plus b minus a divided by 2 multiplied with the new variable t. Then the derivative of x can be written as b minus a divided by 2 multiplied with derivative of t. We can see that when we substitute t is equals to -1, we will get x is equals to a, right? So this for t is equals to -1, x is equals to a. For t is equals to +1, we will get x is equals to b. So the value of x, that is b plus a divided by 2 plus b minus a divided by 2 multiplied with the new variable t, works very well to convert the given limits of integration from a to b to -1 to 1. Now let's solve the integration problem which we discussed in the previous lectures. Let's try to approximate the integral of the function f of x, that is 0.2 plus 25x minus 200x square plus 675x cube minus 900x power 4 plus 400x power 5 from 0 to 0.8 using 2-point Gauss-Legendre integration formula. We are also given that the exact value of this integral is 1.640533. So the integration of this function from 0 to 8 can be written as the integration of 0.2 plus 25x minus 200x square plus 675x cube minus 900x power 4 plus 400x power 5 with respect to x, and the limits of integration are from 0 to 0.8. Now we know that the Gauss-Legendre formula is defined over the limits of integration from -1 to 1. So we need to change these limit of integration first in order to apply Gauss-Legendre formula. So we'll use this formula where value of a is equals to 0 and value of b is equals to 0.8. So the value of x can be substituted as 0.8 plus 0 divided by 2 plus 0.8 minus 0 divided by 2 multiplied with the new variable t, and when we solve this we will get 0.4 plus 0.4 times t, the new variable, and the derivative of x can be written as 0.4 derivative of t. We can also check whether this value of x in a new variable t is okay or not by substituting the value of t, that is equals to -1. We will get x is equals to 0, that is corresponding lower limit. When we substitute t is equals to 1, we will get the corresponding upper limit. So now for x is equals to 0.04 plus 0.4 multiplied with t and dx is equals to 0.4 multiplied with dt, we can change the limits of integration from 0 to 0.8 to -1 to +1. Now substituting the value of x dx into this formula, we can write from -1 to 1 the function 0.2 plus 25 0 multiplied with 0.4 plus 0.4 t. Here it was written x, so instead of x we are writing the new value which is 0.4 plus 0.4 t minus 200. Instead of x square we are writing 0.4 plus 0.4 t plus 675 multiplied with 0.4 plus 0.4 t whole power 3 minus 900 multiplied with 0.4 plus 0.4 t whole power 4 plus 400 multiplied with 0.4 plus 0.4 t whole power 5. Now multiplied with 0.4 dt, this is the value for the dx. Now when we multiply this expression in the parenthesis and we'll multiply it with 0.4, we will get some expression with the variable t. Let's represent that function as g of t. Now we are integrating the function g of t with respect to t from minus 1 to 1. Since the limits of integration are now changed from 0 to 0.8 to minus 1 to 1, we can now apply 2-point Gauss-Legendre formula to evaluate this integral. So this integral value can be approximated using 2-point Gauss-Legendre formula as the function value at minus 1 upon square root of 3 plus function value at 1 upon square root of 3. So whatever the value of g of t we will get from here, we will evaluate it at minus 1 upon square root of 3. We will get 0.516741, and the value of the function at 1 upon square root of 3 is 1.305837, and the sum of these two numbers is 1.822578. And now this number is the required approximate integral of the given function f of x from 0 to 0.8 using 2-point Gauss-Legendre formula. We are also given that the exact value is equals to 1.640533. So the corresponding absolute error can be computed as 0.182045. We can reduce this error further if we apply 3-point Gauss-Legendre formula. This is how we can find the approximate integral of the functions using Gauss integration.